Well, welcome back to the HDR Masterclass. I would very much like to congratulate you for having stuck it through this long, and I think you're going to find that it is this segment that you're going to begin to use the knowledge that you've acquired so far in this presentation and be able to go into the field and perform optimum field capture for HDR photography. So I'd really like to welcome you to this segment where we're going to be talking about capturing for HDR. So let's start by discussing the big picture. Now, as I've mentioned before, the whole process of HDR capture is so that we can obtain a series of images by which we're able to merge during the tone mapping. We're going to be discussing that a little later. But so that we can merge during tone mapping all of the images that we've acquired in the field capture so that we have no clipping in the final merged image. The camera is capturing 8-bit images, and very often the camera's dynamic range is not able to, with a single frame, be able to capture all of the light levels within that scene. So we may have a situation where a particular scene's light levels, be they darks or the shadow side or highlights, the white side, be they a situation where the camera is unable to actually produce a numeric value for the pixels. Obviously, that when that happens, when clipping occurs, we have a situation where there's a loss of pixel information. Obviously, a loss of pixel information is really going to mean that there's a loss of data in our image, in our final image. That equates to basically a damaged image. So the whole point and purpose of a field capture is so that we can obtain enough images where when we merge those images together, we have no clipping, no data loss. Now, there's some other advantages too in our multiple frame image capture sequence, but primarily we're trying to avoid a situation where we ultimately have a loss of data or clipping. Now, let's just take a look at the big picture. So you'll notice here that, as I've made reference to before, we are taking a series of images, and those are going to be 8-bit, 0 through 128 image data. Now, those are going to be merged into a 32-bit during the tone mapping. And when we do this merging, we're going to be able to increase the dynamic range of the final image to, well, as much as 23 EVs. Or EVs could also be referred to as stops. Basically, we're going to get more dynamic range than the camera itself can typically deliver. So then we'll tone map, and that's where we're merging the capture sequence together to form a 32-bit image. And then we can do some additional processing, whatever that may be. We could do some exposure adjustments, we could do sharpening, we could adjust the tones of the colors. There's a number of things that we can do, but we'll have a 32-bit image, which is going to be, it's going to give us a lot of capability for how we process that image. Now, ultimately, the the image that we create in tone mapping is going to find its way in some sort of a presentation method. Presentation could be an LCD screen, a computer monitor, whatever. It could also be a print. Now, it's important to keep in mind that your LCD monitor and your print is going to have a much more narrow dynamic range than your 32-bit image certainly will have. Now, here's the key what we're trying to accomplish with tone mapping is not only merge the multiple 8-bit images together, but actually be able to tone map. That is that we need to remap the tones of our image so that they present properly on low resolution, well, I shouldn't say low resolution, but low dynamic range display devices such as an LCD or a print. Now, ultimately, what we want to do is a number of other benefits, and we've talked about benefits in the past in this presentation, but we're going to wind up with a 32-bit file format, which is going to help future-proof. We're going to have very high-resolution images so that we can actually do more with them than we might have been able to do with the actual 8-bit format. So the big picture is basically a sequence of images which are 8-bit merged together into 32-bit and then tone mapped so that we can adjust the tones of the various pixels within the image so that they can properly display on low dynamic range devices. And certainly along the way, there's a lot of other capabilities that we probably wouldn't have otherwise have been able to enjoy had we not actually had a 32-bit image to work with. Now, the workflow is really pretty straightforward, and I think you've gotten a pretty good appreciation for the workflow as I've made in the presentation here. Well, basically it is do your multiple image capture, merge them in that sequence into a 32-bit file format, and then do your tone mapping and do your other additional processing. So ultimately you actually have a tone mapped image that can be presented on a lower dynamic range display device such as an LCD or print. So the workflow is pretty straightforward. In HDR photography, your typical workflow is really going to be a capture sequence, tone mapping, additional processing, ultimately so that you can display your image on a low dynamic device. Now, the basic point and purpose of field capture of a sequence of captures in the field is that you want to obtain a capture sequence where when you go to process the captured sequence, you have no clipping. And I think by now you probably have heard more about clipping than you care to know about. But basically, we don't want to have a loss of data information. And this is why in the field we want to obtain a series of images where when we merge them together and tone map them, we don't have any clipping in the final image. Now, another key point that I have pretty much focused on as I've developed my own approach to in-field capture for HDR is that we really want a minimum of this shot-by-shot fussing with the camera. We don't need to be in a situation where, you know, you set up the camera in the field and then you set it up and you take a shot, and then you set it up and you take a shot, you set it up and you take a shot. Well, that can get pretty old pretty quick. What we really want to do is to use the capabilities within the camera so that we can have as automated of a shot sequence as possible. Now, we also want to be able to have the capture sequence, or I should say the methods, the techniques that we use for capturing a series of images in the field. We really want that to be repeatable. Again, we don't want to have to think and assess and fuss over all of the various camera setups and everything else that we want to do. We want to try to minimize all of that. This is why I've developed a capture methodology that minimizes the amount of fuss that we do in the camera, and also gives you something that's, for the most part, repeatable. You'll make small adjustments from time to time, depending upon the scene situation you're in. But we really want to be able to utilize HDR methodology without going through a lot of fuss every time. I have found that if I don't have to fuss with the camera, in other words, I do my setup for a capture sequence in the an approach that is minimum fuss and repeatable. Well, I have found that I tend to use HDR methodology far more, which means I'm going to get much better results much of the time. Now, and you know, we really, I mean, if you think about it, it's pretty straightforward. We just don't want to create any more work than we have to. I mean, if you think about it, when you're in the field, well, I mean, you're looking at a scene and you're thinking composition. You're certainly considering the light. You have to think about your camera setup. Do I want aperture priority, shutter priority, what f-stop do I want, and so on and so forth. Well, we don't really want to go into the field with this heavy burden of all of the things that we're trying to remember when it comes to HDR photography. Because if we do that, we're probably not going to use HDR methodology as much as we could have. So a lot of the practice of good habits is really very key. Repeatable, minimum fuss, minimum work, and the idea is to be able to utilize HDR methodology for field capture as often as possible. And so we want to eliminate a lot of the stuff that goes into all of the thinking and the fussing and all of that. Now, we've talked about in a previous segment, we talked about the histogram. The histogram, this is going to be a review because we're coming up on a methodology for actual in-field HDR capture. So in review of the histogram, it really is an important tool for your HDR methodology. Most consumer cameras do have the histogram functionality in the camera. You may not find the histogram in very low-end cameras, maybe a camera that costs a couple $100, or certainly you probably won't find it in compact cameras, and I don't even think you're going to find it most of the time in subcompact or smartphone type cameras. But you'll typically find the the histogram functionality in low-end DSLRs, mid-level, and certainly consumer. So you want to take your camera, whatever model and manufacturer you own, and check to see whether or not you have the histogram. The histogram is going to be an important, if not an essential, tool for your in-field capture. And as we had talked about before, the histogram is the measure of the camera's responsiveness to the light. It will be measuring and graphically indicating to you right on the back of the camera the light intensity and the distribution of the light as the light falls on the photoreceptors of your camera's sensor. Now, a couple little key points here just in review. Keep in mind that the left side, that's the darks right here, all right? The right side is the highlights, all right? And you can kind of use this little memory jogger, light is right. So the highlights or the whites are on the right, and then of course on the left, that's your darks or your shadows. Now, so just in review now, the tonal information goes from darks on the left to highlights to the right. And this hump here, the height is indicating the intensity of the light. Please keep in mind that the histogram is not giving you a graphical representation of the structure of the scene. It is telling you it's giving you a measure of the light density and intensity across the scene. Here's some examples. Let's take a look at the histogram a little bit closer. Keep in mind that we are moving towards using the histogram in our capture sequence. But here, you'll note that the histogram, let's start on the left here first. Let's just start right here. So the histogram is showing that clipping is occurring because the left side, we have the graph is hitting the left edge and crawling up that edge. That's indicating that the camera is clipping, the camera is unable to provide a numeric value for those particular pixels. Over here in the middle, we have a clipping situation on the dark side, the shadows, and we also have a clipping situation on the highlights. Again, it's when you see the graph that's actually hitting the edge of the histogram window, that indicates clipping. And we don't want clipping, obviously. However, when we're in the field shooting for captures, we are often going to have clipping. The histogram is going to tell us that clipping is occurring. And this example here indicates that we are not experiencing clipping, and we are not experiencing clipping on the highlight side. So that's a good place to be. All right, we're gonna pause here. We're gonna end this particular segment, and when we resume, we're going to continue talking about in-field capture for HDR photography. So go get yourself a hot cup of coffee or tea, and please join me again. I'll see you in a few minutes.